Bismillahirrahmanirrahim. Welcome to the second part of the topic definite integral and its properties. We say that the definite integral of the integration is just integration with limits, upper limit and lower limit for the integration, and we need to find the value of the function between these two limits, a and b. And in general, we said that this will give me a value, real number in general, which is different from the indefinite, where we are looking for the antiderivative, which is a function, not a number, not a finite value. The last time we gave different type of example how to find the value for the definite integral. We are going to continue now to give more examples for definite integral. Evaluate the following integration. So number one, relation of x sine 2x between 0 and pi. X multiplied by sine 2x. In this function, I have multiplication of two functions, x and sine 2x. And the x given there is not derivative of some function in sine of 2x. I have x to the power 1 and the angle is 2x to the power 1. So it is not a derivative, which means I cannot apply integration by substitution. But we can think about the other technique, which is that integration by parts. I mentioned this before, that if one of the function is derivative of another one, or somehow we can relate it to the derivative, we use the integration by substitution. But if we cannot, then we have to use the integration by parts, like what we have now here. This is, I'm going to use integration by parts. Let u equal to x, dv will be sine 2x dx. Now differentiate the first one and integrate the second one. Differentiate and integrate. We differentiate u, I will have du equal to 1 dx. Integration dv, I will have v equal to minus 1 over 2 cosine of 2x. Cross the integration by parts, it is u times v minus the integration of v du. So this will give me, it is u v minus integration of v du. This is the integration by part. So I will have minus 1/2 x multiplied by cosine 2x, and the limit between 0 to pi, we shouldn't forget this one, minus integration of minus 1/2 cosine 2x multiplied by du, which is 1 dx. So it will be minus 1/2 x cosine 2x plus minus with minus is a plus, so it will be plus 1/2. Integration of cosine will be 1/2 sine 2x. From 0 to pi. So this is the integration of the given function. It is 1/2 x cosine 2x plus 1 over 4 sine 2x. Now find the value, replace x by the upper limit first, and then the lower limit. So this is equal to minus 1/2 multiplied by x is equal to pi cosine of 2 pi plus 1/4 sine of 2 pi. This is the value of the function at the upper limit minus the value at the lower limit. That will be minus 1/2 multiplied by 0 cosine of 0 plus 1/4 sine of 0. Find the value of the function at the upper limit minus the value at the lower limit. You can see that the second part is this is 0 and this will be 0. And also this is 0. So it is equal to 1. So the answer is minus pi over 2. So the value is equal to minus pi over 2. We apply the integration by part to find the value of the integration. Let's take another one. Find the integration of x multiplied by secant square dx, and that will be between pi over 6 and pi over 4. X cosecant square of x. Again, this can be done using integration by parts also. Let u equal to x and dv equal to cosecant square. X dx. Now integrating the differentiating the first one, du will be x. If we integrate the second one, v will be minus cotangent. Now the integration now is equal to is u multiplied by v. So this is equal to x or minus x multiplied by cotangent of x minus integration of, so this is should be du equal to 1 dx minus cotangent of x times dx with the limits from pi 6 to pi over 4 is equal to minus x cotangent of x plus minus with minus is a plus. Integration of cotangent can be written as sine x over sine dx. This one can be integrated by substitution. It's u equal to sine x. G will be cosine. Then the integration for this one will be ln of sine. It will be minus x cotangent of x plus ln of sine of x. And this will be pi over 6 to pi over 4. Integration of cotangent equal to ln of sine of x, or it is absolute value of sine x, but since we are in the first quadrant, sine x is positive, so no need to write the absolute value. It is ln of sine of x. And then this will be minus pi over 4 multiplied by cotangent pi over 4 plus ln sine pi over 4 to the upper limit minus the value at the lower limit. That will be minus pi over 6 cotangent pi over 6 plus ln of, it should be written down, and now we have space. Is minus pi over 6 tangent plus ln sine pi over 6. You can use the calculator to find the value for this one. Cotangent pi over 4 equal to 1 plus ln sine pi over 4, which is, that will be ln of square root 2 divided by 2 minus pi over 6 divided by cotangent pi over 6. That will be square root of 3. This is 30. That's 60, and we are looking for the tangent. This is 1/2 square root of 3, and the tangent or the cotangent is 1 over, this is square root of 3 plus ln of square root of 3 divided by 2. Use the calculator to find the value for this integration. This is the idea of this problem. Let me take one more problem. Number 3. The integration of sine inverse between 0 and square root of 3 divided by 2. We mentioned this type of integration in the topic of integration by parts. This can be done also by or using integration by part. Let u equal to sine inverse x and dv equal to 1 dx. Now differentiate the first one and integrate the second one. Du equal to 1 over square root of 1 minus x squared dx. And v will be x. Integration by part is u multiplied by v and minus the integration of v du. So the integration from 0 to square root of 3 divided by 2 sine inverse will be x multiplied by sine inverse is u times v minus integration of v x times du, which is square root of 1 minus x squared, 1 over square root of 1 minus x squared dx. This one can be done by integration by substitution. For the second part, let u equal to 1 minus x squared. So du will be minus 2x dx, or dx can be written as du divided by minus 2x. It will be integration of x multiplied by sine inverse x. I will write the limits at the end. Minus integration of x divided by u to the power 1/2 multiplied by du divided by minus 2x. X will cancel this one. Minus 2 with minus outside. It will be x multiplied by sine inverse x plus 1/2 integration of u to the power 1/2 or minus 1/2 du. That will be x multiplied by sine inverse x plus, for the integration, add 1 to the power, it will be 1/2, and divide. I will have 1 over 2 multiplied by 2, because we will divide by the power, which is 1/2. This is 1/2. If we divide it by the power, it will be 2 multiplied by u to the power 1/2. Now I have x and u. I have to write u back as a function of x. Then I will use the limits of the integration. So this is equal to x multiplied by sine inverse x plus, this will cancel, it is square root of 1 minus x squared. Now write the limits. The limits were 0 to square root of 3 divided by 2. In the last 3 steps, I didn't write the limits. It can be written, but I left it to the end. This is from 0 to 3 over 2, all of them. But for the second part, since we changed the variable to u, I have to change the limits, or I will just find the function, I will integrate it, then I will write it back as a function of x, and then I use the original limit for x, which is between 0 and square root of 3 divided by 2. Now find the value. It will be square root of 3 divided by 2 sine inverse of square root of 3 divided by 2 plus 1 minus by 2. This is the upper limit minus the lower limit. That will be 0 multiplied by sine inverse of 0 plus square root of 1 minus 0. So this is equal to square root of 3 divided by 2 sine inverse of 3 over 2 is by over 6. It is by over 6 plus square root of 1 minus 3 over 4 minus 1. This is this one. This is equal to 1. You can use the calculator to simplify this value. So it is square root of 3 divided by 2 multiplied by over 6 plus square root of 1 minus 3 over 4, or it is just only 1 over 2 minus 1. Just make it, want to simplify it more. It will be pi over 12. This one is 1 over 2 minus 1 will be minus 1/2. So this is the value of the integration. We use integration by parts to evaluate it, then we found the value of the integration.